right, so any non-zero number to the 0 power is going to be 1. Now with that, we're going to take and write some examples of if you have a variable to the power of 0, it's still 1. If you have a negative number to the power of 0, it's still 1. Also, if you have just a regular number to the power of 0, we still have the answer of 1. So we're not going to spend a ton of time working on that property right now, but we'll pick up on that later. Any non-zero number to the negative n power is the reciprocal of the number to the nth power. So example 1, remember, to be a reciprocal, all you need to do is have a fraction to start with. And if you don't know how to make something into a fraction, remember, it's easy to just put whatever it is over 1, and then you can easily take a fraction and make it the reciprocal by flipping that over. Okay, so example 1 says write each expression using a positive exponent. So we went ahead and put the 1 on the bottom, and now we're going to take the 7 and write that with a positive 3 for the exponent on the bottom. And then the 1 just flips to the top, and that's our final answer. For B, again, we do the same thing. Put a 1 on the bottom, flip the fraction over, which is our reciprocal, and make it a to the positive 4th. Okay? So pretty simple stuff there for example 1. Now when we move to example 2, to evaluate the expression, so the word evaluate is going to tell us that we need to solve this out. So the first part of it is exactly what we did in example 1. We're going to go ahead and put a 1 under the bottom. We're going to flip that over, so the 1's on the top, the 5 comes to the bottom, and the negative 4 becomes positive 4. But then we're going to go one more step, which is to make the answer to the 5 to the 4th power. So that's 5 times 5 times 5 times 5, which gives us a total of 625 on the bottom. Okay? For B, we're going to do the same thing. Please take notice here that if we have a negative number for our base, like we do in letter B, that the negative number still stays negative when we flip that fraction over. The only thing that's ever going to change from negative to positive is the exponent. So our exponent becomes positive 5, but the negative 3 stays in parentheses. Okay? And then again, because it said evaluate, we're going to take it one step further, and we're going to end up with 1 over negative 243. All right, example 3 is a little bit different. This is when we're asked to take a positive exponent and go back to a negative exponent. That's fairly rare that we do that, but just knowing that you can go either direction, to positive to negative or negative to positive, is a good thing. So if we started with 1 over 6 to the 5th, again, all we have to do is just flip that fraction like we've been doing, and it becomes 6 to the negative 5th on top over 1. And then also remember, anytime we have a fraction that has a 1 on the bottom, that's not really necessary, so we could just write it as 6 to the power of negative 5. All right, example 4 is where they start to pick up the properties from 1.3 and 1.4 of, adding our exponents together and subtracting our exponents. And so that's what we're doing here in example 4. The directions say simplify, and then we need to express our answer using only positive exponents. So here we're going to keep our same base of x, and we're going to take our exponent of negative 3 plus 5, which gives us x to the power of 2. And on this one, we already have a positive exponent, so that is our final answer. Letter B, same thing, except this time we have the quotient of powers. And so with quotient of powers, we keep our base of w, and this time we are using subtraction. Please take note that anytime you have a subtraction of a negative number, it's really like that's going to turn into negative 5 plus 7, which is really 2. All right? So our final answer here would be W to the second power. And again, because it's positive, we are done. Sometimes you're going to end up with a negative number there, and then you would have to do what we did in example 1, taking the fraction and flipping the fraction over to make it negative, or to make it positive. All right, on the back of the paper, we've got some exercises here. So the examples are very similar to what we did on our notes, okay? So we're going to go ahead and put a 1 on the bottom and flip that over. So it's 1 over a to the power of 8. Number 2, put a 1 on the bottom, flip it over, 1 over 6 to the third. And number 3, put a 1 on the bottom and make it reciprocal, which is 1 over into the fourth. All right, our next set of problems, again, goes to evaluate, which, as a reminder, that means to solve it out, so to take it one more step than what we were just doing. So put a 1 on the bottom so that we can get rid of the negative exponent. And then we're going to go one more step, which is to solve 7 squared, which makes 49 on the bottom. All right, number 5, same thing. Go ahead and flip the fraction so that we can get the exponent to become positive. And then we're going to take it one more step, which is 1 over 729. And number 6, same thing. Put a 1 on the bottom, flip it over to get rid of the negative exponent. Please remember the negative 2 stays in parentheses. And then our final answer would be 1 over negative 32. Okay? Our next option here would be to go ahead and write each fraction as an expression using a negative exponent. So, again, we flip the fraction over. So 5 to the negative 7th goes on top. If you'd like, you can put a 1 on the bottom, or you can just leave it as 5 to the negative 7th. Same way with number 8, 3 to the negative 6th on top, 1 on the bottom, or you can leave the 1 out and just make it 3 to the negative 6th power. Same thing for number 9, we're going to flip that over, so it would be x to the negative 8th over 1, or you can just leave it as x to the negative 8th. And the last things, okay, we are going ahead and combining those properties of 1, 3 with our 1, 5 stuff here. And so we're going to keep the base in number 10. Notice that our directions say we're going to simplify and only use positive exponents, okay? So we're going to keep the 4, we're going to add negative 2 plus negative 4 together, which is negative 6. But because my answer has a negative exponent, I now need to go back and flip that over to get rid of the negative exponent. Okay, same way for r. We're going to add negative 3 plus 5, and we end up with a final answer of r to the power of 2. Because 2 is positive, we do not need to make this into a fraction and flip it over. 12 is h to the negative 2nd minus 4, and that would give us h to the negative 6th. But again, it's a negative exponent, so we want to go ahead and put a 1 on the bottom and flip the fraction over. So 1 over h to the 6th. So that's our lesson 1.5 notes.